Hi everyone. Good afternoon, guys. Right, very good afternoon of you. How are you all? Right. So here we'll be going for this. We'll be continuing our discussions. You can say on this quick revision of this SOM. You can say. So what is that we were discussing? If you just remember, some portions we have discussed now. So no, and we'll be continuing those portions. You can say. So today we'll be discussing about this shafts, torsion of this shafts, and also which one we'll be discussing. You can say that a torsion of this shafts and what torsion of this shafts and which one springs we'll be discussing in today's class. You can see which steps, right? Okay, that's some quick revision series we'll be having. All of you, welcome to Unacademy. Let's crack it, right? This is GATE and ESC for civil engineering. So this is my profile. You can follow me at which, right? RP Civil. Right, what is that referral code you have to use always? Right, that RP Civil is the referral code you have to use always. You can say, is na? Now, so these are all GATE 2024 toppers, right? Those who have secured AIR 1 from Unacademy, and now you can get this GATE subscription, right? GATE subscription at this 50% off for you on your GATE and ESC subscription, right? Harry Brook, hi. So now it is available at which one? This 5,999 rupees only, and this offer is extended up to which date? Tell me. Yeah, good afternoon, good morning. Right, November 16th it is extended. You can say. Now, GATE 2025 subscription, it is available for 3 months at 5,999. So what is that referral code you have to use? Tell me. RP Civil. Now, so it is 2026 subscription for 15 months. It is available at this 14,999. Right. Uh, now, okay, a little bit, yeah, it's good only recently, right? In the recent days, I am not feeling well, right? So that cold, cough, everything got affected, right? That's why, so I was not taking classes also regularly also, right? So this GATE 2027, if you just observe, what is it? You can say 24 months subscription you will be taking it. Which one? This is 19,999 rupees, no? And so what are the courses started for this 2025 aspirants, right? Those who are willing to write this GATE examination for this 2025, it is available at which one? This is October 11th that the latest batch was started. So geotechnical by this Amit sir, and recorded and live you can have, right? Highway we have done, we are doing, right? So what is that referral code you have to use, right? RP Civil is the code you have to use, right? And for this 2026 aspirants, right, from 15th November onwards, right, these subjects are starting, right? CPM part by KP sir, railway and airport for GATE by this myself RP sir at 7:45 p.m. and engineering mathematics by this group also will be starting, you can say, right? For 2027 aspirants also the same will be started, you can say, is not? uh, uh, YouTube classes are taken on smartboard only. Who said? Did I say that I will be taking? No, actually, last time, right, just before the last month, right, not this November, right, before this November, right, October, September, right, in September month, they said that those who are having only smartboard have to take, right, no, yeah, railway for ESC also means actually I will be discussing that gate portion only, that is your geometric design of this railway track and this is geometric design of this airport, right? That part only I will be discussing, you can say, okay? That part only I will be discussing, right? And it will be useful for ESC also, right? After gate examination is over, na, these extra topics for this ESC I will take, right? So railway extra part and ESC extra part I will take, right? So that what will happen? Your gate examination will be covered as well as the ESC examination also will be covered, you can say, is not? Now, okay, harbor tunnel also will be coming up after the gate examination, right? So that what will happen? Yeah, why gate only means, right? Because now time available is lesser, na? Haribrook, right? Now the time available is lesser, na? Time available is lesser, so that's why we have to focus first on the gate examination. So that's why whatever the syllabus is there for gate, we are taking that, okay? Then after that, right, what happens? We have to focus on this ESC examination, right? So we will be discussing the extra topics of this ESC, right? So that what will happen? We can utilize this time, right? Instead of because we are having lot of time after this gate examination, yes or no? So some 4 months, 5 months, 3 months, 4 months time available, na, yes or no? If you are discussing now itself, our focus, if you are discussing the extra topics of this ESC now, right, what happens, tell me? Your focus from the gate will be little bit deviated, na? That time you can utilize for some other extra topic of this gate, na? Some other topic of gate you can cover in that time, na? So that your full focus will be there on the gate only, right? So after the gate is over, the extra topics of this ESC we will discuss, right? So that what will happen, na? Both examinations will be covered, right? Both examinations will be covered, right? Yeah. They said that in the September that only faculty with smart board has to take the class, right? But upon request, right, they have allowed some number of hours for which one this all faculty, right? Those who are not having the smart board also, right? Is not those who are not provided with the smart board also, right? That's why we are taking. So my classes will be less, only 2 hours class will be there, okay? Yeah. These 2 hours only will be there, right? 2 hours only will be there. I am keeping every day 3 p.m. class, na? So from day before yesterday onwards, I am doing it. So don't worry. So every day the classes will be happening from now onwards, right? No need to worry. Okay? At 3 p.m. Either in the special class it will happen or in the YouTube class it will happen, right? No need to worry. Okay? So now this Unacademy GATE scholarship tested UGST will be there. Yes, na? Sir, project planning, budget, how to do. Okay, you just text me. I'll be sending you the list of books and any references. I'll be sending it. Okay. So Sham, you just text me. I'll be sending those details. Right. But here I cannot say all these details, right, because it will take a lot of time. Right. Whatever the doubts exactly you're having, you just ask me there, and in detail I'll be giving the explanation. Or any reference books also there. I'll be sending the PDFs, and if I'm not having them, I'll be sending the names also. Okay. That would be better. Right. So the scholarship test you can win laptop, tablet, and 100% scholarship is also possible to get, you can say, right? So based on your rank, you will be getting which one? Rank 1, 2, 3, 100% scholarship, and you will be getting the benefits if your rank is above this 501 also, right? Yes, na? So don't miss this opportunity. And when is this test you are having? On 24th November at this 11 a.m. you are having, okay? Now, so here what is that you can say, based on your 2023 and this 2024 ranks, right? Based on your gate rank, you will be getting that 90% to 60% scholarship, and based on your ESC prelims qualified and ESC mains qualified, you will be getting which one? This 90 to 80% scholarship, right? And based on your college details and everything also, right, you will be getting which one? This 55 to the 75% scholarship you will be getting, right? So these are all the features of this plus subscription you are having. Yeah, yes, this is there now here. 80% and this above marks, right? That CGPA converted to which one? Tell me. Percentage, if it is matching with that 80% and above, you will be getting which one? This is 70% scholarship, right? So for that you need to scan this QR code and fill the form, okay? For that, Harry Broke, right? For that, what is that we need to do? You need to scan this QR code and fill the details, right? So then they will be giving the code for you, okay? Right. You just scan this QR code. You just take this screenshot, and after the class is over, you just scan this QR code, right? And fill all the details in this form given, okay? Right, these are all the features of this plus subscription. Iconic subscription, if you are taking everything that is there in the plus, and along with that these extra features you are having, right? So these printed books you will be getting if you are taking which one? Iconic subscription, you can say. You just observe, right? Now coming to this, right, which session we are doing, that 19th session we are doing now, 2021, right? With that, what happens, you can say, SOM will be over, right? Just 2 or 3 sessions more, SOM will be over, okay? Mostly 2 more sessions only, that SOM quick revision will be over. So the SOM quick revision columns and this direct and this bending stresses we had done in the previous class, na? 109, 110, 112, 114 points we have seen, na? So no, this direct and this bending stresses. Now 114 points. Now coming to this torsion of shafts and this is springs, right? We'll be seeing this. So 114, and this is your which one? This 115 point will be going for, right? 115 point onwards, right? We'll be discussing, you can say, just of the right. So and in case of this shafts, right? What is it? You can say in case of this shafts torsion, what is that a torsion equation? Tell me that a basic torsion equation, if you just observe. Anyone having idea, right? What is the basic torsion equation? that a torsion equation, right, similar to that of your bending equation, m by I equal to f by y equal to that E by R, that a torsion equation also you will be having. Na? What is a torsion equation? Tell me. That is your T by J is equal to, what is it? T by J is equal to, that is C theta by this L is equal to, that is tau divided by this R, you can say, right? This is the equation for which one? This is a torsion, if you just observe, right? Okay. Or if you wanted to write it, you can also write it as which one? PDF. After this quick revision is over, you just ask me, I will be sending it, okay? Because all I will be adding in this same PPT only, I am continuing all of them. So once this quick revision is over now, you just ask me, I will be converting them into PDF and I will be sending that PDF to you, okay? Right. So R, what is that? You can say T by J will be equal to which one? This is G theta by this L equal to, what is that? A tau by this R, you can say. Right. So what is that T, you can say, if you just observe, T is nothing but you are that a twisting moment or this a torque, na? Twisting moment or this a torque or not? G or this is C, right? Either you can use that G or you can use that C, or you can use sometimes which one, this N also, right? So what is that? G or this is C, that is your rigidity or this is shear modulus, na? That is a rigidity modulus, or you can also call it as which one? This is shear modulus, you can say, if you just observe, right? Rigidity modulus or this is shear modulus, right? So G or T, right? What is that L, you can say, if you just observe, or this is J or this IP. J you can use, or IP also the symbol you can use, right? What is that? You can say it is your polar moment of inertia, no? Yes or no? It is your polar moment of inertia, if you just observe, right? Whenever you are having this circular section, what is it you can say? This is your cross section we are having, na? So no, this is your cross section at x axis and this y axis you are having. And what is this? You can say this diameter D will be equal to the 2 times that radius, na? Yes or no? Generally for circular section, right, what is it you can say? Mostly for this circular section, so what is it you can say? That so this polar moment of inertia, that J is equal to that IP will be equal to which one? Tell me. That is Ixx plus which one? This Iyy, right? Do you remember this? Polar moment of inertia, that IP or this J will be equal to which one? This Ixx plus this Iyy, na? Yes or no? Ixx plus which one? This Iyy. Ixx plus which one? This Iyy, you can write. Whenever it is for this circular section, what is that Ixx and this Iyy? Tell me. That Ixx will be equal to that Iyy will be equal to which one? This tell me. That pi d power 4 by this 32, na? So therefore, what is that IP or sorry, pi d power 4 by this is 64, right? Pi d power 4 by this is 64, na? Pi d power 4 by this is 64, you can write. What is that IP or this J is equal to? Same, pi d power 4 by 64 plus this pi d power 4 by this 64. 2 times pi d power 4 by 64. What it will become? Pi d power 4 by this 32 it will become, na? Yes or no? Now, here that tau or this Q. What is that tau or this Q? You can say it is the torsional shear stress, right? Which is shear stress? Is it the direct shear stress or it is the torsional shear stress? You can say, if you just observe. It is the torsional shear stress, na? Torsional shear stress means it is a direct shear stress or it is a indirect shear stress, you can say. It is a indirect shear stress, na? It is a indirect shear stress at which location? Tell me. At a distance. At which distance? At a radial distance. At a radial distance smaller from where? Tell me. From center of this shaft, na? From center of which one? This shaft, you can say, if you just observe, right? Is it clear this point? The torsion equation and what is that each and every term in this? What is that L, you can say, if you just observe. L is nothing but you are that length of which one? Shaft. L is your length of shaft. And what is that theta, you can say, if you just observe. Whenever it is subjected to this torsion, that twist will be there na, that angle of a twist, right? By how much angle it will be subjected to this twisting, that is called as your, which one you can say, that is called as your angle of twist. Okay, note this and tell me everyone. Note and tell me everyone. Noted everyone. Shall I move to the next? All of you. Shall I? 116 point. Okay. So here, right, how it will be if you just observe it, whenever you are considering a circular section, you are having, if you just observe, this is your circular section, let us say, and this is how the shear stress variation you are having, if you just observe, right? At this radial distance or from this center, right, what is the shear stress you are having? That is your shear stress tau you are having, na? That is your shear stress tau you are having, right? What is it? Tau is equal to that q is equal to, that is your t by this j divided by this r, right? Okay, what is that? You can call it as that twisting moment divided by this zp, right? Zp is which one? Tell me. That zp is nothing but your, it is not the plastic section modulus, it is your which one? This polar section modulus, na? It is your polar section modulus, you can say, if you just observe, right, that j by this r will be called as your polar section modulus, right? Then that tau will be equal to which one? This gr theta by this L, right? We can get it from one more expression also, right? Like that we can get it, yes or no? The expression for this, if you just observe, right? Is it? This is 116th point, you take it as, right? Next, what is it? 117 point, you can say, if you just observe regarding this torsion. So this tau is directly proportional to that radial distance, na? More radial distance means that more tau, right? This is your tau maximum you are having, na? This is also which one? This is tau maximum you are having, na? At this which place you can say this is your capital R, right? At this capital R you will be having this tau maximum or not, right? Is it? Now, what is that torsional rigidity? Tell me if you just observe. What is that torsional rigidity? That torsional rigidity will be equal to that GJ, na? Right? So if the torsional rigidity increases, right? Suppose if that torsional rigidity, that GJ will be higher, means the rigidness will be higher or lesser, right? Rigidness will be higher, right? Rigidness will be higher means, right, what is it? You can say that stiffness also will become higher, na? Stiffness becomes higher means that deformation theta becomes lesser, you can say, if you just observe, right? Is not? Theta becomes which one? This is lesser, right? Now what is that next one? That is your torsional rigidity. Now what is that torsional stiffness? Tell me. What is the formula for this torsional stiffness, everyone? That torsional stiffness Kt will be equal to how much? Tell me. Twisting moment divided by this T, right? Or you can also write it as which one? This is Gj by this L, right? Both will be exactly the same only, okay? Right? This is your which one? This is a torsional stiffness you are having, right? Now, whenever you are using this shaft, what is the power of this shaft? Tell me. What is the main purpose of a shaft? Tell me. It will be transferring the power from this one element to this other element, na? Yes or no? So now what is that power transmitted by a shaft? If you just observe, main purpose of this shaft is to transmit the power, na? Now what is that power transmitted by a shaft? Anyone having idea? Yeah, here this is your center, na? No, this is your center, if you just observe. Okay, I am repeating. This is your center of this shaft, if you just say. And what is this? Right? This is your total diameter, that is your 2 times the radius, or this diameter, you can say. Now at this r distance from your center of this shaft, what is the shear stress you are having? That is your tau or this q shear stress you are having. So how can you get that tau or this q? Same this only na. T by j equal to that tau by r. You just send this r to other side, right? What it will become? T by, yes or no? T into r by this j na. That r will come to the denominator. J by r it will come na. T by j by r. Okay? T by j by r. What is that j by r? Polar moment of inertia by this radial distance is polar section modulus ZP you are having, right? And from this one, how can you get that? From this one, if you are using for this one and this one, or if you are sending to other side, g into theta into this r will come g into theta into r by this l, g into theta into r by this l, right? Now understood how these expression, that 116 expression comes into picture? Is it clear now, Hari? Right, that 116 expression comes like that, right? And if you remember that AE is called as your which one? If you remember that AE will be called as which one? This axial rigidity, na? AE will be called as your axial rigidity, right? Rigidity means what? It will be trying to be in the same condition under the action of a force also, na? Yes, na? Now EI will be called as your which one? This flexural rigidity, right? So rigidity again is the flexural deformation, right? Now that GJ or this CJ will be called as which one you can say? That is your torsional rigidity, na? That is your torsional rigidity you can say, right? That is a resistance again is the deformation, torsional deformation, right? When that torsional rigidity is higher, stiffness also will be increasing. Therefore that theta angle of twist decreases, if you just observe, right? Got it? So now torsional stiffness is what? Torsional force divided by this deformation. What is the torsional force? Twisting moment T divided by this theta deformation. So from this only T by theta if you are taking, T by theta you bring it to left side, J you take it to other side, right? Cj by this L or Gj by this L it will come, right? Is it clear now? Is it clear now, Haribrook? The meaning of this? Now power transmitted by this shaft, that P will be equal to, what is it can say? That a twisting moment T into that angular velocity, which one? This omega, right? What is it you can say? Angular velocity omega, na? Yes or no? Now how can you rewrite this if you just observe that P equal to, that is your 2 pi into that capital N capital T divided by which one? This is 60 you can say. Is na? So whenever you are having this shaft, that shaft will be rotating like this, na? Whenever it is at N given, how many rotations per minute, na? RPM, right? N is in terms of which one? This RPM, rotations per minute, right? That is your W rotations. W which one? This you can say, right? W, right? W we are having, or you can also use the symbol which one? This omega symbol also we can use this, right? So what is this? You can say this is your angular speed, na? That is your angular velocity or not, right? That angular velocity you can say P steps, right? Isn't it? Now so here what is that power you will be getting in? That power you will be getting in this Newton meter per this second, or what is another unit? That is your watt, na? Yes or no? What is the unit of this power or not, right? This N we have to substitute in which unit? That you have to substitute in this RPM, and capital T you have to substitute in which unit? That is your Newton meter, right? That is twisting you can say, is na? Torque or this twisting we have to substitute in that, right? And what is another formula we can write it if we just observe? That is your 2 pi N by this 60 into, in place of capital T, right? What is that we can write if we just observe? That is your pi d cube into the tau maximum divided by this 16, right? How this came actually if you just observe? Because that tau maximum will be equal to which one? That tau maximum will be equal to which one? Tell me. 16 T by this pi capital D cube. Okay? Yes, no? What is the tau maximum? 16 T by this pi capital D cube, right? Tau maximum, tau is what? T by this ZP, na? Yeah. Yes, I am good. How are you? T by this ZP, na? J by R, right? What is that J by R? You can say J is nothing but your pi d power 4 by this 32 divided by this R is nothing but your d by 2. So this dd cancels, pi d cube by this 16 it will become, right? Pi d cube by this 16 it will become, right? Isn't it? That is simply that T by this ZP only, no? That ZP is nothing but your pi d cube by this 16 only, right? Simply already. You substitute that T equal to which one? that capital T equal to tau max into pi capital DQ by 16. You substitute it here, you will be getting this equation, right? So you wanted to get this power equation either in terms of this angular velocity omega, or in terms of this rotations per minute and twisting moment, or in terms of this maximum shear stress, right? In any manner you can get it, right? That power transmitted will be directly proportional to that diameter cube. More diameter means that more power we can transmit, right? Less diameter means that less power we can transmit, you can say P steps, right? Is it clear now? Yes, na? Now here okay, yeah, I forgot you. Tell me, who are you? That Lina ghost, right? Uh, now if you just observe, what is it? You can say safe diameter of this shaft if you wanted to select. What is the safe diameter of this shaft? If you just observe, safe diameter of this shaft based on this stiffness consideration. If you are considering that stiffness, right? Stiffness consideration, you can say. You are human, not ghost. Very good, right? So what is that? You can say, if you just observe that the D safe will be greater than or equal to which one? Tell me. That is 32 capital T small l divided by which one? This pi into that G into what is it? You can say that theta whole power how much? You can say that is your 1 by 4, right? So I'm not going for the derivation of this one, right? In the full length course of the SOM it is already discussed. It is just a revision course now, so you have to remember the formula, that's it, right? Nothing else, okay? Like that. Now this is based on which consideration? You can say that is stiffness consideration, son. That is stiffness consideration you are having or not, right? Now based on another condition, you remember the first formula only. Very good. Now you try to remember the other formula also. Remaining all gone. Very good. So that is why I am taking this quick revision, right? So that you can recollect them back and you try to remember again, right? So what is that next? Is safe diameter based on which condition? Tell me. Safe diameter based on which one? This is shear stress consideration, right? Based on this shear stress consideration, right? That is based on the stiffness consideration. This one, it is based on the shear stress consideration, right? Like this we have to select, right? So what is the D safe? You can see, if you just observe that D safe will be greater than or equal to how much? 16 capital T by which one? This pi into that tau maximum whole power how much? You can say that is 1 by 3 na. There it was 1 power 1 by 4, but here it is power 1 by 3, you can say, yes na. So which one we have to select among these two? Higher among these two we have to select, na. Definitely higher among these two we have to select, right? Higher among these two we have to select, right? Now tell me, right, what is that a maximum shear stress? If you just observe, what is that a maximum shear stress? You can say that tau maximum is equal to that is 16 capital T by this pi d cube, right? This is for which section? Tell me. That is your solid circular section with the diameter capital D, na? And that tau maximum also will be taken equal to which one? Tell me. That is 16 capital T divided capital T into that capital D divided by which one? This pi into capital D power 4 minus this small d power 4, right? When we have to take this, you can say you have to take this for which one? This is a hollow circular section, hollow circular section with this inner diameter is a small d and outer diameter will be that capital D, right? Like that. Is it clear now? Yes, now? Right? Now coming to this side, we will be comparing which one? You can say we will be comparing the shafts, na, sana, right? Comparison of what? Comparison of which one? This is solid and hollow circular, right? Solid and which one? This is hollow circular shafts. So there are different conditions you are having, right? What is the first condition? You can say, right? What is the first condition? You can say, if you just observe, same weight is there for both. Weight will be same for both. Then how can you get this power? If you just observe that a power of this hollow divided by this power of this solid, right? is equal to, okay, shall I write this fully? Power of this hollow divided by this power of this solid will be equal to, right, how much you can say? That is your k square plus 1 by under root, what is that you can say? Sorry, k square plus 1 by this k into, right, what is that you can say? K into that under root k square minus 1, right? What is that k you can say if you just observe? K is nothing but your diameter of this outer by this diameter of this inner, ratio will be same, right? Weights we are equating, same weight we are having, and so means same weight means that weight of this hollow will be equal to which one? The weight of this solid, right? When the weights are same, this is a ratio of which one? This is a powers, you can say, right? This is a ratio of which one? This is a powers, right? And comparison of this strength. How can you compare this strength under this same weight only? Same weight only. What is the strength? The torsional strength or this twisting strength? Na? That T, right? What is that T1 by this T2? You can say, we just observe that T1 by this T2 is nothing but your same k square plus 1 by same, you can say, we just observe k into under root, what is that? K square minus 1, right? So that means this is your T hollow divided by which one? This is T solid, you can say, right? This is also the same, na? Yes. Now, so it is given as which one? This same torque is given, same torque, and this, yes, k is, what is the k I have given here na? K is nothing but your dO by this di, right? So what is the dO by this di means, right? How can you get that dO by this di if you just observe? This is your outer diameter, that dO, and this is your which one? This inner diameter, what is the, you can say, that is your di, okay? And for this solid, right, what is that you are having, right? That is your weight d, sorry, diameter d, okay? dO by this di is nothing but your outer diameter to the inner diameter of this hollow section, outer diameter to the inner diameter of this hollow section, right? Is it clear now? What is it, k? Now, so here same torque and this same material we are having. When you are having this same torque and this same material, then if you are comparing the weight, what is it you can say? Weight of this hollow to produce the same torque, and both are made up of the same material, then what is that ratio of this weight? Weight of this hollow by this weight of this solid, that will be equal to which one? Tell me. That is k square minus 1 whole power which one? This 2 by 3 divided by, what is it you can say? K power 4 minus 1 whole power which one? This 2 by 3. No. We are comparing, na? So we are just taking it, right? Weights are same we are taking, na? Weights are same we are taking, na? So no, you have to be careful. Weights, same weight we are having, na? Right? Weight of this solid will be equal to that weight of this hollow. When you are taking that, right, what is it you can say? Length will be same, and area we have to take it same. What is that area? Pi by 4 into, what is that? D naught power 4 minus this di power 4. Sorry, d naught square minus this di square equal to that pi d square, right? Pi cancelled, right? Pi by 4 cancel, right? So d naught square minus this di square equal to that d square, right? So you are comparing with which one? This d naught by this di you are taking it, and d naught by this di you are taking it, right? And you simplify, right? Everything you are getting in terms of which one? This d, and substitute d will get cancelled, you can say, okay? Which formula? This formula, this one 123 formula, or this 123 A or B? Which formula you are saying? 123 A or B? One, two, three, A or B? Which one? You will be getting them in terms of this, na? Right, okay, 1 second, I'll show it, right? You will be getting this in terms of this, na? Yes, na? You will be getting that in terms of it, na? So here, what is that we are doing? So you are, okay. So this is your B part formula, right? What is that you are having? Weight of this hollow by this weight of this solid. That is only we are comparing, na? So k square minus 1 by this k power 4 minus 1 whole power 2 by 3, right? For maintaining the same torque and this made up of the same material, right? What is that you can say if you just observe that T by J will be equal to which one? This tau max divided by which one? This capital R, that is your d by 2. No? Yes or no? That is capital R is nothing but your d by 2. No? So no, capital R is nothing but your d by 2. You can say, right? T will be same means that what is that T? You can say that T will be equal to that J into what is that tau maximum divided by which one? This R maximum. Na? So this d by 2 is nothing but your, right? What is that? You can say that d by 2 is nothing but your R maximum. You can take it. Na? Yes or no? Now when you are equating this T1 is equal to that T2, if you are equating, right? When you are equating that T1 to this T2, right? What happens? Tell me. When you are equating that T1 to this T2, right? What is the T1? Tell me. That is J. Numerator में k square minus 1. Yes, right. K square minus 1 into k power 2 by 3. Okay. That you are asking me to check. Yes. Correct. Yes. Suppose if it is k square minus 1 power 2 by 3, no need to write again, na? Yes or no? Because this will be cancelled, na? Denominator and numerator 1, further simplification will come, na? Into that k power 2 by 3 will come. Yes, correct, right? K power 2 by 3 divided by this k power 4 minus 1 whole power 2 by 3. Yes, that is correct only. So how it came if we just observe this one J? You are substituting the value of this hollow, value of this solid, then d not by this di you will be taking it as k, then everything you will be getting in terms of this d only. Okay, so that is how that dd will get cancelled and nothing will come regarding that. Now what is that next one? You can say, so if you are having this same weight, okay, you are having this same weight, next same material, same weight, that is same material, okay, same weight, same material, and which one? This is same length, na? Same length. Yeah, actually, okay, I'll show this here, right? What is that? You can say, or here you are taking that weights are equal, that will be easy to consider. So whenever you are taking that weights are equal, right? What is the weights are equal? That W1 is equal to that W2, na? W of this hollow will be equal to the W of this solid you are having, na? Yes or no? What is the W of this hollow? You can see if you just observe, length is also same, means what is that? Area only we are having, na? So that is pi by 4 into that d naught, right? What is it? You can say that d naught square minus this di square is equal to which one? This d square you are having, right? So what is that? D naught square we can write it as d naught, you can write it as this k into that di we are writing, na? K square into that di square minus this di square equal to the d square, right? Now tell me, right, what is that di square? If you just observe, di square is equal to that d square divided by which one? That k square minus 1. So now everything you write in terms of which one? This di you can write in terms of this d. Do also we can write in terms of this d, na? You can write this do also in terms of this d, na? So everything you substitute in terms of d, denominator d will be there, numerator also that di and this do also you substitute in terms of d, that d is cancelled in the numerator and denominator, only that k will be left. Is it clear now how this comes into picture? So there is no inclusion of this solid property, so how come it will be for both? That is what your doubt, right? Isn't it? Is not? Is that your doubt? Got it? So you get this di in terms of this d and do also in terms of this d, right? How can you write that? That do square minus di square, how can you write? Right, do square divided by this k square, na? Equal to the d square. So now we can get to which one? Tell me if you just observe that do square, na? That do square will be equal to which one? This d square. Okay, d square divided by this 1 minus 1 by k square, right? So do you are getting in terms of d, di you are getting in terms of d. So numerator hollow, what happens? Tell me. Di you write in terms of d, do you write in terms of d, denominator solid you write in terms of d. So numerator d's and denominator d's, d powers will get cancelled, right? So now that d will be there or d will not be there? Tell me if you just observe. D will be left or d will not be left? Is that clear now? Is it clear? So same weight, same material and this same length you are having, then the ratio of which one, this is strain energy for this, right? So strain energy for this hollow section divided by this, which one, tell me, that strain energy for this hollow section divided by this strain energy for this solid section, if you just observe, equal to what is it, you can say, that is your k square plus 1 by this k square, right? Like that, this is what the comparison we are having, you can say, right? 123. Got it now? Okay, yeah, but both are included, right? Both are included, right? Both are included in it, right? No need to worry. Right, okay, leave it then. Just you remember the formula, right? That is important. Right. So here, okay. So this is the comparison of which one, this you can say. Okay, you remember the formula, right? Don't worry about this, right? Derivation of this one, how it has come. See, whatever the condition it is given, you just apply that condition, you will be getting this relation directly. Okay, just equate torque T of hollow equal to T of solid. Same material, tau maximum of hollow equal to tau maximum of the solid, right? Then you will be getting that automatically, right? The relation between that solid and this hollow you will be getting, right? So you convert everything into the solid in terms of solids. Okay, then you can get it easily. This is your 123 point, and next 124th point, if you just observe, right? What is the 124th point, you can say combined shafts. So just we'll see this combined shaft and we'll close the session. What is the combined shafts, if you just observe? Whenever that combined shafts are there, first shafts are in this series, na? Whenever they are in this series, right? What is the, you can say, if you just observe, this is your fixed support, right? What is that you are having? This is your first you are having, and this is your second shaft you are having, na? First shaft and this is second shaft you are having. For both shafts together, that a T only will be applied, right? What is it? That the diameter of this shaft will be D2 and the diameter of this first shaft will be how much, you can say, that is your D1, right? So here that T1 is equal to that T2 is equal to that T, right? Torsion will be same in both, you can say, if you just observe, this is your first shaft, this is your second shaft, right? Now what is that theta, you can say, if you just observe that angle of twist, that angle of twist theta total is equal to that theta is equal to which one, this is theta 1 plus this is theta 2. Okay, what is that theta total? That is nothing but your TL by this GJ, it comes to be, na? TL by this GJ it comes to be, right? This is a relation. And now what is that L, you can say, if you just observe, L is nothing but your L1 plus this L2, na? Because this is your L1, a length of this first shaft, and what is this, right? This is that length L2, so L you are getting like this, right? T is applied torque, right? GJ you are getting like this. Okay, now whenever the shafts are in parallel, how can you get that? Whenever that shafts are in parallel condition, right? What is that shafts are in this parallel condition, you can say here, at the junction that a twisting moment is applied, if you just observe, right? At this junction that a twisting moment T is applied, right? The diameter of this will be D2, the diameter of this will be which one, this D1, right? And what is this length, you can say, that is your L1, and what is this length, you can say, that is your L2, if you just observe, right? Here T will be equal to reverse, na? Exactly reverse, right? T will be equal to that T1 plus this T2, first shaft plus this second shaft distribution, right? So now theta 1 is equal to which one, this theta 2 is equal to that theta, right? What is it, T, you can say, that is T1 L1 by this G1 J1 is equal to, what is it, you can say, T2 L2 by this G2 J2 we are having, right? This is for the shafts in which condition, tell me? Shafts in this parallel condition. Okay, got it now? Clear? Okay, I'll be closing the session. Again, tomorrow we'll be having this session only, and we'll be continuing in that, right? Yes, no? Any doubts anyone having till now? So I'll be closing the session. So these many points we have discussed, right? From where? 115.2 which one? 115.2 which one? This 124 points we have discussed, right? Okay. Thank you. Thank you. Have a good day. Again tomorrow class.